Good day, everyone. In this video, I'm going to discuss the continuity of a function. We are going to determine whether the given function is continuous at a point or not. I will also show to you the graph of the given function to have a better understanding of the concept. Now, let the function f be defined for all values of x near x equals x sub 0. The following definition uses the limit of a function. So the function f is called continuous at x equals x sub 0 if the limit of f of x as x approaches x sub 0 is equal to f of x sub 0. Note that the previous definition implies the three conditions which must be met in order that a function f be continuous at x sub 0. Now, here are the three conditions. First, f of x is defined at x sub 0. That is, we will show that f of x sub 0 exists. Next, the limit of f of x exists. That is, we will show that the limit of f of x as x approaches x sub 0 is equal to L. So this is the limit L. And the third is the limit of f of x is equal to, or rather the limit of f of x as x approaches x sub 0 is equal to f of x sub 0. That is, we will show that L is equal to f of x sub 0. In other words, we are going to show that the first condition is equal to the second condition. We also note here that if one of these conditions fails to hold at x sub 0, then f is said to be discontinuous at x sub 0. Now let's consider here an example. We have here a function f from the set of real numbers to the set of real numbers defined by this. We have here f of x is equal to 2x if x is not equal to 1. And then 0 if x is equal to 1. So we will show here the three conditions to determine if the given function is continuous or not at a given point. Now here we choose x sub 0 be equal to 1. So let us choose x sub 0 be equal to 1. Then we will show letter A. For the first condition, we will try to find f of 1 because our x sub 0 here is we defined as 1. We have chosen that as 1. So f of 1 is equal to, so from the given definition of a function, when x here, by the way, we can replace x by x sub 0 because x is equal to x sub 0. So when x sub 0 is equal to 1, we have f of x sub 0 is equal to 0. Okay, so that is for our first condition. Then the first condition is satisfied. Okay, let's have now the second condition. Let's try to show the limit of f of x where x approaches to 1 because our x sub 0 is equal to 1. So let's have here the limit of f of x as x approaches to 1. Now take note here, when x approaches to 1, it means, by the way, x is not equal to 1 means x is less than 1 and x is greater than 1. Hello? So let me have here an illustration for the values of x. So if this is 1, for the values of x here greater than 1, less than, x less than 1 is to the left of 1. And okay. And then here, x, by the way, this is x is less than 1. And then for x is greater than 1, the values are going to the right of 1. So 1 is not included here for this. For x is not equal to 1, then our f of x is equal to 2x. Hello? Now here, if you are to find the limit of f of x as x approaches 1, so we are to find the limit from the left and then from the right. So we're done with this already. So the limit of f of x as x approaches 1 based from our given definition is 1. We have the limit of 2x. F of x is equal to 2x when x approaches 1. Hello? Therefore, the limit of this is 2 times 1, which is equal to 2. And of course, this is our L. So that is the limit of f of x. Now, we have here L is equal to 2 from our second condition. And from our first condition, we have here f of 1 is equal to 0. Now, let's proceed to our third condition. Our third condition here states that L is equal to f of x sub 0. It means the first condition, the result in the first condition is equal to our result in the second condition. Now notice here in our first condition, we have 0 and it's not equal to 2. Hence, our third condition here based on our example is not satisfied, right? So we can conclude that f is not continuous. Here, f is not continuous because the third condition is not satisfied. So let's have here is not continuous. Okay, it's not continuous at 1. Or we can say that f is not, or rather f is discontinuous at 1. Now, to have a better understanding to the continuity or discontinuity of a function, here is a graphical representation of the previous example. So as you noticed here, we have here a hole in our line. So this is a point of discontinuity at x equals. And so as you can see here, our line is not continuous. So it is not continuous at x equals 1. Now let's proceed to the next example. We will also be using the 3 conditions here to determine whether the given function is continuous or not. So based from this given example, we will be considering a function g. This function g is from the set of real numbers to the set of real numbers. Now let's choose x sub 0 be equal to 3. So here we will be testing whether the given function g is continuous or not at point 3. So let's have here the first condition. The first condition is, by the way, our function here is g. So we have g of x sub 0. So we will be showing that g is continuous at the number x. Now, g of 3 is equal to, okay, we have here the defined function. So we will just be substituting 3, x equals 3, into 5x minus 1. So we have 5 times 3 minus 1. So we are replacing 3 here. Okay, that's why we have this one. Now we have 15 minus 1 is 14. Let's proceed to the second condition. So the first condition is satisfied. It means g of 3 exists. For the third condition, we have the limit of g of x as x approaches 3 is equal to the limit of 5x minus 1 as x approaches 3. So this is equal to 5 times 3 minus 1 is also 14. So this is our L. Now for the third condition, we will show this one. L is equal to g of 3. Now notice here that g of 3, our first condition, is equal to 14, and in the second condition, the limit is equal to 14. Hence, the third condition is satisfied. Therefore, we can say that G is continuous at point 3. Follow? We're testing here the continuity of a function at a certain point. Now, here is the graph of the function g defined by g of x equals 5x minus 1. Now, notice here that at x equals 3, our f of x is equal to 14. In our graph, our line rather is continuous. There is no hole at point x equals 3. Hence, the function g is continuous at x equals 3. Now let's have here a remark. It states that if f is continuous at x sub 0, then we have here the limit of f of x as x approaches x sub 0 is equal to f of the limit of x as x approaches x sub 0. Now we can restate the previous remark as follows. If the limit of f of x as x approaches 0 is not equal to f of the limit of x as x approaches x sub 0, then f is not continuous at x sub 0. Let's consider here an example. Actually, this is our previous example, first example. So we have here the function f defined by this. So we will be showing this remark to show that the function is continuous or not. So we will be showing this or this one. So if we have this result in the remark, we can say that the function is continuous at a point. But if they are not equal, we can say that the function is not continuous at a given point. Here, we choose x sub 0 be equal to 1. Now, we will show first this one. So we have limit of f of x as x approaches 1 is, of course, equal to 2. So we're done with this already. Now, let's have this one. But first, we will be looking at the limit of x as x approaches 1. So for the limit of x as x approaches 1 is, of course, this is equal to 1. Actually, this is one of the properties of the limit of the function, that if the limit of x approaches where x approaches to a constant 1, then the answer is a constant. Now, to show this one, f of the limit, we will put f here of the limit of x as x approaches 1 is, of course, equal to f. We'll just be putting f here. So we have here f of 1. Now here, when x here is equal to 1, so for x equals 1, f of 1 is 0. Now, as you can see here, based from our results, the limit of f of x as x approaches 1 is 2, which is not equal to f of the limit of x as x approaches 1, because it is equal to 0. So as a result, we have here f of x as x approaches 1 is not equal to f of the limit of x as x approaches 1. Hence, we can say that f is not continuous at point 1. Hello? So we have the same answer, but using different solution. So because we are using the same example, and then here we're using different way of determining the function, whether it is continuous or not at a given point. Now let's have the second example, wherein the function g is defined by g of x equals 5x minus 1. Now here we choose x sub 0 equals 3. So we will be looking at this first. We have the limit of g of x because our function is g at x, where x approaches 3 is equal to 14. So we're done with this a while ago. Now let's have this. So let's have this first, the limit of x as x approaches to 3 is equal to 3. Hence, g of the limit of x, which is 3, is equal to, you have this one, we just replace 3 here. So we have 5 times 3 minus 1 is equal to 14. Now, as you noticed here, that the limit of g of x as x approaches 3 is equal to 14, which is equal to g of the limit of x as x approaches 3. Hence, from the previous remark, we can say that g is continuous at point 3. So that's it. As simple as that. So that's all for now. Thank you for watching and listening. I hope you have learned a lot. So God bless everyone.